We will start the session with Unit 6 from Jan 2024. In this question, a student is investigating the oscillation of a stretch spring using an apparatus shown. A student gave the mass a small vertical displacement and release it. He used a stopwatch to determine the time period of oscillation. Describe how student should determine an accurate value for the time period. So if you want to determine a time period, um, what we should do, we should record the time for 10 oscillation or 5 oscillation and then divide it by the time recorded by number of oscillation, then repeating the experiment. So when we really reset the stopwatch, because we want to explain experimental procedure. So first thing, we should reset the stopwatch. Then after resetting the stopwatch, what we should do, we should record the time for 20 oscillation. Or you can also say 10 oscillations or 10 vibrations and divide the time recorded by number of oscillation. So these are the points we should include whenever a question is there related to finding a time period. Okay. And repeating an experiment, take average. But not only say repeat experiment, like mention how many times, at least mention repeat experiment 5 times and take average or mean. These are the points you should include. Student attached the spring to a vibration generator. As you can see, the spring is attached to a vibration generator. Then a student used a signal generator to vary the frequency. So he changed. Actually, what will happen when it's a concept of a resonance, when the applied frequency is equals to the resonant frequency, like when applied frequency is equals to natural frequency, the object will vibrate with a maximum amplitude. So when it vibrates with the maximum amplitude, what we call that phenomena as resonance. So this is, as you can see, the amplitude of a vibration and the frequencies. Determine the F naught. What is F naught? The resonant frequency. What is the meaning of the term resonant frequency? The term resonant frequency means frequency for which the amplitude of vibration is maximum. So what we have to do, we have to draw a line from our graph, like the maximum amplitude. This is the place where we have a maximum amplitude. So even at these two frequency, like this range, any of the frequency I can take, and I'll work out what is the resonant frequency, because this is a maximum amplitude region. Then determine the value of M, where K is given. When you have to, here, as you can see, the formulas are given. You have the resonant frequencies there, the formula which relate the time period or for a object vibrating. This is unit 2. T is equals to 2 pi under root M over K. So we need the value for M. T is equals to 2 pi under. So how we will work out the value for T? T is a time period. So time period you can find from the frequency, as the time period is a reciprocal of the frequency. So we have the formula T is equals to 2 pi under root m divided by k. We have to determine the value, but first how to get the t? T is a reciprocal of the time period frequency. Frequency and time period are reciprocal of each other. So using this, we'll get the value for t. So that will give us t. And then you just have to substitute the values and solve, make m as a subject and solve. Like, so if we square both sides, this will become t square. This will be 4 pi square m over k, because if I take a root and then cross, if I need m, so it will be t square k divided by 4 pi square. That will be equals to m. So using this, we can work out the value for m. Explain why your value for f naught may not be accurate. If this graph is plotted, when this graph is plotted, we have the range, like we don't have maximum values in this region, because for accurate, because we estimate, as you can clearly see, when we sketch this result, maybe the graph is like this, maybe the graph is like this, maybe the graph is like this. We are not sure about the maximum amplitude. Because we don't have many values in the maximum, at the maximum amplitude. That's why our value for f naught will not be that accurate, as we don't have many results or the values around this maximum value. So this is a, the best fit line is having a greater uncertainty. Why it's of 2 mark? First point you will mention that not many points around the maximum or the peak, near the peak. And the second thing, so the line of a best fit, because this is the line of a best fit and it is having a greater uncertainty. If I have more points, then my line of a best fit will be more accurate. But if I have few points, then my line of a best fit won't be that accurate. So this will have a greater uncertainty if you have few points. So what you will write here, you will mention few points at the maximum amplitude, means the line of the best fit will have a greater uncertainty. Is it clear? Explain why your value for f that we did. The next is student suggested that the motor sensor in a data logger, motion sensor, sorry, the motion sensor which can sense the motion in a data logger arranged as shown would be an improvement, would improve the experiment. How using a motion sensor and data logger would improve the experimental results, or will improve the experiment? Because motion sensor, first thing, as we have a motion sensor, it can detect the motion of the oscillating mass, and the data logger, it can record greater number of values in a short interval. That is the most important thing. Like, and it can sketch the results as well. So when we use a data logger, so it will have a lower uncertainty. The first thing, because when we are using a data, why it will have a lower uncertainty? Because it can collect more readings in a short time, or in the same time, it can collect more readings. Like when the mass is oscillating, when we are calculating, we are just calculating when it complete 20 oscillation or it goes up and then come down, we record one result. But a motion sensor with a data logger, what will happen? When it is moving, every second it is recording the motion. So we will get an interval like what is at what position it will be at a higher amplitude. So the answer here, whenever we use a data logger with any sensor, like motion sensor with a data logger, so we'll have more results, or we can say we will have a greater sample rate. Sample rate means like more result can be collected, and as a result, it will lower the uncertainty, because when we'll have more results, the uncertainty will be minimum. In question 2, a student investigate the cooling of a hot water using an apparatus shown. A thermometer is there, main power hot plate is there, heat proof mat is there. A student use a hot plate to heat the water until it boils, and he remove the glass beaker on the heat-proof mat and allow the water to cool. Identify one safety issue and how you dealt with it. Like you're dealing a hot water is there. So when you're handling a hot water, what should be or you can see the hot plate is also there. So hot plate or the hot water beaker that can cause a burn if you touch. So what else you can use? You can use the insulated gloves the best way. Can't we talk about adding a lid to prevent the spillage? If you mention adding a lid, but the thing is, we are investigating the cooling of a hot water using an apparatus shown. So this apparatus which is shown, this only you have to, if they say what additional thing can be added, then you can mention that. But if adding a lid will, it's not a safety precaution while adding a lid, like the water will not spill if you add a lid, that's fine, but it will also affect the rate of the cooling. That's why adding a lid will affect the apparatus, like in the experiment. So hot plate touching a hot, like you may get touched or you may touch a hot plate or a hot beaker. So you don't want to touch that. So use a gloves for that. Then a student suggested that the relation between the temperature of a water and the time is given by a theta is equals to theta naught e raised to power minus bt. Theta naught is the initial temperature, b is a constant. Devise a method to investigate validity of this relation. And your method should use a suitable graph. Look, whenever you see such this, how you simplify this equation, you will take ln both sides. Using a gloves, yes, using a gloves is fine also. Insulated gloves is of different types. So main purpose of the glove is for, so if you mention gloves, that's also fine. Taking ln, first thing you want to simplify this equation whenever you see this. And we have to outline this of 6 marks. So devise an investigation. So we want to explain the method as well. First, I will simplify this equation. So if I take ln both sides, so this will be ln theta is equals to ln theta naught e raised to power minus bt. When ln and two quantities are multiplied, we write them as addition. So ln theta is equals to ln theta naught. Theta naught is the original temperature. Ln e raised to power minus bt. If I ln theta is equals to ln theta naught, my ln and e will cancel minus bt. If I rearrange this equation, so I can say ln theta is equals to minus bt plus ln theta naught. Then I will compare with the equation of straight line y is equals to mx plus c. On y-axis, if I plot ln theta, but it's not only mathematical equation I have to solve, it's of 6 mark, and I have to method to investigate as well, to validity of this relation. So on y-axis, I will plot the temperature change, and on x-axis, I will plot the time. What will be my gradient? My gradient will be minus b, and the y-intercept will be ln. So it's a negative, b is a constant dimension. So even I can predict what will the shape of the graph. It will have a y-intercept and a negative gradient will be there. This will be the graph. Now, what we will do, how we perform this experiment. So first we will reset the stopwatch. Reset the stopwatch and we'll record the initial temperature of a hot water. Like recording a temperature of a hot water, the initial temperature of hot water, that will be theta naught. Then we'll start the timer and record the temperature after like 30-second interval for 3 minutes or 5 minutes. Or for 10 minutes, we can say. So simply what we have to do, we have to reset the stopwatch first. We'll measure a time, record the initial temperature, then we start the timer and we record the temperature for after 30-second interval for 3 minutes or 5 minutes, okay, until it reaches a room temperature. And then we plot a graph between ln theta on y-axis and t on x-axis. One more thing, important point about this experiment, because in a water, the heat does not uniformly transfer. So whenever we want to measure a temperature, we should one time stir and then record temperature. Like, let's say I want to record a temperature after 30 seconds. So I will just stir one time, but it's not stir very fast, just stir gently and then record a temperature. What is the main reason for stirring? As the water is not in a water, in a liquid especially, that the heat does not transfer at same amount or same rate uniformly, so we have to stir it. But it's not, it should be gently stirred, but otherwise if you stir at a higher rate, then what will happen? That will also contribute to rate of a cooling. Is it clear? And then we plot a graph between ln theta and t. And because we want to check the validity of this result, like equation, so it should be a straight line, and that is with a constant gradient, constant negative gradient. Is it clear, this part? Any doubt in this? So this is question 2. Next question 3 is there. Very short paper. It's next we will do